Good evening and welcome to Hardfire. I'm Ronald WIECK, your host for the third segment of our three-part debate on the collapses of the Twin Towers. My guests, as you probably remember from the previous two shows, I have Tony SZAMBOTI in the studio with me. He's a mechanical engineer, and I have Ryan MACKEY on webcam from LA. Ryan is a NASA scientist. Before we get into the topics we have been hammering about, I told Tony that I would tax him with the Osama conundrum. Since we're talking about conspiracies, we have to deal with the question of conspirators. I mean, someone has to be behind this conspiracy. I'm going to read what I wrote and posted, and we're not going to belabor the issue, just a few thoughts. Either Osama's repeated explanations of his role in the attacks of 9/11 are genuine, or he's being impersonated by an exact double, an asset of the impossibly vast conspiracy. If you acknowledge the reality of his videos, your entire movement collapses. You must therefore argue against all evidence that the Osama the world sees isn't real. Now let's pretend you're correct. You aren't, but we'll pretend. In the fall of 2006, Bush and Cheney were staring at a massive defeat that would strip them of much of their power and pave the way for a Democratic takeover of the presidency in 2008. That, in fact, happened. In the face of this looming humiliation, they could have announced that the bogeyman, the non-existent Osama, had at long last been killed. They could have, in other words, snatched victory from the jaws of defeat. Curiously, they chose to do nothing and accepted a battering at the polls. Given that neither Bush nor Cheney will ever again run for public office, this was absolutely the last chance to play the Osama card. Well, who will swallow the idea that Bush and Cheney preferred taking this beating that wrecked their second term? What's the solution to the Osama conundrum?
Well, first of all, I don't think that if those behind 9/11 were not 19 hijackers and Osama, and I don't think they're the whole story, and the FBI does not have any hard evidence against bin Laden.
Well, wait a minute. The FBI thinks that bin Laden did.
They don't have anything about 9/11 on his wanted poster. I thought that was odd when I heard it.
The Washington Post story explaining that covers it pretty well.
I didn't read that Washington Post story. You'll have to explain that. But the point is that we do know the FBI has nothing on their wanted poster for Osama bin Laden about the 9/11 attacks. Also, the Osama bin Laden video that was found, where he supposedly admitted to it, was found like a needle in a haystack in a house in Jalalabad in Afghanistan.
But
I don't know.
Every news outlet in the Middle East accepts these as authentic.
I have no idea whether Osama bin Laden was involved in 9/11 because I haven't seen any evidence of it other than the purported tape of him saying he was. I don't know, Ron. I don't have enough evidence to say
But what I'm
either way.
saying is that if he's not, if this is an actor portraying him, why don't the evildoers just say, "Hey, we killed him. We're not so inept after all. We got the bad guy."
I don't know that any conspiracy, U.S. conspiracy behind 9/11 would have to just involve George Bush and Dick Cheney, or just Republicans either, for that matter.
Now we're getting somewhere.
Because I don't see any Democratic congressmen taking up the issue that they should to reinvestigate the crimes and how those buildings collapsed.
But that's because they think it's preposterous.
No, that's not. They don't have. They think it's preposterous.
I mean, Noam Chomsky hates America.
Noam Chomsky's not an engineer. Noam Chomsky wouldn't have any idea how to argue whether the buildings came down or not. So he's irrelevant to the conversation. I think he's completely irrelevant. You have to get into the engineering, and I haven't seen real proof that those buildings came down. And there is a dilemma here. Brian admits there's no jolt. Building 7 came down in free fall for 100 feet or 8 stories. That's pretty hard to do without something removing the strength of those columns unnaturally. So we have an engineering dilemma that we have to solve. And anybody that doesn't want to look into that is being disingenuous in some way. And I think we need to have a rational, civilized debate about this, recognizing real problems. And you know what? If there is a natural, innocent solution, so be it. We don't have that yet.
I thank you for a game effort, and I want to get back to the physics. I just want to leave the viewers with this question in mind. Osama's videos are real, there is no truth movement. If they're not real, then obviously Bush and Cheney missed a big opportunity to spare themselves a massive, massive, crippling defeat. Ryan, I don't want to continue with this particular thread. Let's go right back to the physics, the jolt. Should we have expected to see a jolt?
Sure. Yeah, once again, thank you for having me back.
Our pleasure.
Tony asked a good question. He says, are there some engineering answers to these questions? Why did World Trade Center 1 see no jolt? Why did World Trade Center 7's perimeter fall, practically free fall for some period? And there are answers for these. There are answers that don't involve explosives, that don't involve nanothermite or anything like that. I put together a number of slides that describe this. I'd like to walk through that briefly. Yeah, if you could bring up the second one. I have a disclaimer I like to run. I don't like disclaimers, but every time I appear, there's always some kid who says the government is paying you to do this, and you're at the beck and call of your masters. It's not true. I don't work on this for a living. Everything you see here is completely on my own time. If you want to contact me by email, go ahead and do that. So I'm not trying to argue from the strength of the job I do. I have experience with engineering issues, but I'm doing this completely on my own. So with that out of the way, if you can go ahead to my slide number 3. I've got 2 pictures here, and this is relevant to understanding why we don't see a jolt. The picture on the left is a picture of what the floor systems look like as they're being installed. Now, on top of this, there's going to be a few inches of concrete poured, but you can see the kind of connections we're dealing with, and you can see how relatively lightweight these are. You have to understand the World Trade Center was a unique structure because it was efficient. It was designed to carry a lot of weight without itself being particularly massive. And this works as long as everything stays in true, but it doesn't give you that much resilience once you start getting off nominal. The second picture, the one on the right, is also taken from the NIST report. This is from the chapter that deals with the collapse. And this shows a photograph of World Trade Center 1 right as it began to collapse. I've added that red line, which is tracking right up the side of the corner of the building. The original doesn't have that red line, but I put it there to illustrate the tower that's on top of World Trade Center 1 demonstrates there is a substantial tilt going on. We know this happened. We have photographs of it happening. We have video of it happening. We have to accept that this happened in order to understand why there's no jolt. If we deny that this tilt happened, and you can't do that because there's a photograph of it, then you might conclude that the jolt is weird. But once you accept this fact, then there really is no problem.
Tony wanted to make a point here. Tony, you do see the tilt.
Yeah, but this is a couple seconds into the collapse. It did tilt.
Wait,
2 seconds.
Wait, how can you say that? Why do you
Well,
think that's
first
true?
of all, this doesn't give, because video shows that it doesn't tilt until a couple seconds into the collapse, Ryan.
No,
There's
that's-
almost an insignificant tilt, and I'll show you a video that...
Tony, you've made this amazing claim that you know when this photograph
Well-
was taken to the second.
well-
How do you know this?
Well, because I've
I
watched
think you're
the
making
video.
it up.
This does no frame-by-frame analysis of this video. All they do is put this one picture in there and say, see, it tilted. No,
Tony?
we want a little more than that, and that's what I'm
Tony?
asking for.
I'll give it to you.
All right,
It's coming up.
you need a frame-by-frame analysis, and you need other videos from other perspectives which don't show a tilt until it drops a few stories.
Ronna, if you could go ahead to slide number 7. I'm jumping around a little bit, but Tony wants to force the issue. So
Okay,
we'll
Ryan,
force the
I
issue.
do want you to come back to slide number 4.
I will do that, but Tony's asked a question, and I'm going to give him the answer. Let's go ahead to slide number 7. Tony said that he needs people to do a frame-by-frame analysis to see if there was really a tilt occurring. Well, guess what? A lot of people have done frame-by-frame analyses, and these are not people that work for NIST. These are not people that work for the government. These are people, some of whom are in the truth movement. This picture that I'm showing you is from an extremely detailed frame-by-frame analysis looking at that antenna before the collapse happens. And interestingly enough, they've got extremely good resolution. In the first couple of seconds before the collapse that's obvious, you can actually see that antenna start to tilt and start to descend. Now, I don't know if you can see this on the TV, but there's a red line that fits through that jagged curve there. That red line is a model based on the assumption that the upper portion is tilting, and it's tilting because of buckling columns on the perimeter that are facing it. I give credit for where you can find this. This is on Gregory Yerkes' forum. So, Tony, what you've asked for, I've provided. People have done a frame-by-frame analysis, and they've proven that this effect is true.
I'm going to have to get back to you on this graph because I don't.
Incidentally,
it's enough.
Gregory Urich was known as a member of the Truth Movement, but he has contributed some remarkable work. I think he is really commendable for his objectivity and for his dedication to finding the real
yeah,
science.
he's very
behind
objective.
it.
He tries to be very objective.
I mean, I had jousts with him on the James Randi Forum, and frankly, I owe him an apology because he is, in the best sense of the word, a scientist, and he is a seeker of
Well,
truth.
he's an engineer. He's an electrical engineer
Yeah.
from Sweden, and
So,
I think he's
Gregory,
he's
if
an
you're
objective
listening,
person.
I think you're a good man.
I would agree with that.
Yeah, I agree.
So the point is, we have pictures that show a tilt, and maybe you can argue over exactly what second it tilted at, but we have additional evidence. The simple fact is, as the upper block was descending, there is a significant tilt. Ron, maybe you want to go back to slide number 4 now.
Yeah, 4 I found interesting.
Yeah, this is it's a cartoon, but it's relatively to scale. The width is correct, the height is correct, the approximate location of the perimeter and the core is correct. We're talking about 8 degrees of tilt. That's what NIST reports. They report 7 or 8 degrees around one axis and 2 to 3 degrees on another. What this shows you is because of the dimensions of the building, once you've tilted 8 degrees, you don't have floors falling squarely on floors anymore. They're hitting on an angle. And also because you're tilted, the upper block is coming down tilted, it's coming down corner first, and it's going to come down inside the lower block. This is important to understanding why there's no jolt. If you want to go ahead to slide number 5, we were talking about Gregory Urich. These are pictures that he wrote, and Tony, I know you've seen these because these were in a paper that he submitted to the Journal of 9/11 Studies that you were a reviewer for so many years. That was never published.
I wasn't a reviewer for that paper. The one paper I reviewed of his was published, the mass analysis.
All right, well, this particular paper,
So you got to watch what you say there.
they gave him this really interesting excuse that they weren't going to publish anymore, so they denied this
I
particular
wasn't
paper.
involved in that at all, Ryan.
I'm glad to hear that because it was really rather callous of them, I thought.
Just as a quick aside, the Journal
Sure.
of 9/11 Studies can by no stretch of the imagination be regarded as a peer-reviewed journal. Is that correct?
That's correct. It is an advocate-reviewed publication. And
Well-
if you want to check this, just look at the people who've published it.
What is peer reviewed? So peer review is, Ryan's saying it's an advocate reviewed, okay, so he changed the wording there, and I would tend to agree with that. Most people who are doing reviewing do advocate that there is more than meets the eye to 9/11.
Well, there you go.
So I'm not going to argue, but that doesn't mean it's not peer reviewed. You just changed the wording. There are people looking at it.
No, it does mean it's not peer-reviewed. It doesn't mean that they're wrong. You can publish a white paper without review, and that doesn't mean it's wrong.
Well, you did it
But
yourself.
you cannot call it a peer-reviewed paper.
Your paper itself fit that description, right?
That's right. I never claimed otherwise. You guys, on the other hand, have claimed
Well,
it's peer-reviewed.
peer review, they're saying in the Journal of 9/11 Studies is somebody else qualified as reviewing it. What you're trying to say is these people are biased and they're going to go along with something that's not objective. I don't see evidence of that.
They're all in the truth movement.
Well,
Of
I don't
course
see
they're
evidence
biased.
of bias. Just because
That
we're all
is
members of the
bias.
human race doesn't mean we have to reject.
Questions
Or of
come
one
up
race or
about
another.
Richard Gage's group. There are members of Gage's group who can frankly be described as the lunatic fringe. I mean, you have a fellow who works on oil rigs who claims that the towers were nuked. Now, again, I'm not tarring you with that brush. I'm not saying you're a crackpot.
Look, somebody.
But you sign up as one of
Yeah, but that
Greg's
you can't.
Gage's group.
There's most people in Gage's group are very lucid and objective. There's almost 900 engineers there.
Are there really?
Yes, there's 800.
I find almost
at
no real
this point, I
structural
think
engineers.
there's 30 of them, and all the mechanical engineers had structural courses. Ryan's a mechanical engineer, and so am I. And we're no different than the civils in the sense of our structural engineering courses.
If you guys don't mind, I'd rather talk about the science.
Let's
Go
go.
back to slide 5 here.
Slide number 5. Okay, so these are graphics that Gregory Urich put together. He's drawn this to very good scale. He's showing the floors, the locations of the different lines of columns, and he says what happens when we put in a tilt. What happens? So the top picture on slide 5 is the base case where there's no rotation. You probably can't see it, but he's marked little X's where he thinks the breaks are going to occur. The next slide, he shows it starting to tilt. You see 3 degrees of rotation, and then when you go on to slide number 6, he shows 6 degrees, and then he shows 8 degrees. So you see what's happening here. Because of the tilt, the columns are sliding past each other. The floors are starting to pile up on one side. you don't have a nice flat geometry anymore. So at the bottom, at 8 degrees rotation, this is the point at which the hinge is completely broken, and the upper block will start to fall straight down because there's nothing in it that's going to give it a sideways force anymore. So my question is, since this is what happened, this is what we started with, we see this on video, when do we expect to see a jolt? How far does that thing fall after the 8 degree case before you see a jolt? Is it a foot? Is it 3 feet? Is it 6 feet? Where does it happen? How far does it fall before the jolt?
Well, personally, I don't agree with Gregory's analysis here.
Why not?
Because I think there would be, well, I don't agree with the fact that there's no jolt required, because you're still,
Then where is it? Where does it happen?
you're still breaking the building. I have a video I'd like to show that people should see.
No, come on, answer the question.
I don't believe there still should be energy losses commensurate with that should cause a velocity drop when it destroys the floors, whether it's angled
If
off
you
or
won't
not.
answer, I'll answer for you. The reason there's no jolt is because you don't have a solid simultaneous impact. You have individual columns breaking through floors at different times. And that's why there's no jolt.
And I've told you before, the aggregate, the cumulative effect of that would still be the cause of velocity loss. It's
No,
still
it's
happening
spread out over time.
It's still happening over a very short time interval.
How short?
Less than a second.
A second is plenty.
Yeah, no,
to
it's
smear
not
that.
plenty of time, because you should be losing about 76% of the velocity when that happens.
No, because
would
you're
be
spreading it out
measurable.
over a second. At the same time, you've got gravity working that whole second, and so there never is a net deceleration. You spread it out, there is no jolt.
You know what, Ryan? I'd love to see you try to build a model to do this.
Gregory did it. It's right
Gregory
here.
didn't build a model to do this. And when you can't break the columns one at a time.
Why not?
You know what somebody else said about Gregory's point here, and I think a lot of what Gregory's done has been very good. This is not. And somebody
wrong
made the
with it?
comment that Gregory thinks the upper block sculpted the lower section of the tower to dust. I don't think it happened that way, and I'd like to show this video if I could. Can I show you this, Ron? And we can get
Ryan,
in here?
can we interrupt your slides to see his video?
I have no objection.
Okay,
I'm
let's
talking
take a
about
look.
the video. You have this, Ryan. It's the one with the North Tower, and it shows it going up and down. And what I'd like to do, I can show this, and I want Gary to do this. You can drag the slider, and I want you to tell me it starts to tilt, but not initially. You see it coming down?
I see the
now
tilt
you'll
now.
see. Now you see the tilt. Now the antenna's tilting up. It's not tilting initially. That's coming down. The front and the back are coming down at the same time. They're trying to tell us that, oh, it just hit one beam here and one beam there, one beam here and one beam there, and you don't have enough of an energy loss. And
Well,
that's
they're
not-
saying a series of discrete impacts that are happening
Okay.
very quickly.
All right, and I'll say this. If I have a car that's moving at a certain speed with a certain energy, and I hit a series of discrete impacts at a very short time interval, it's going to have the same energy loss as it would if it was one impulse.
But you're
It'll
not
be-
looking at the total energy loss. You're
Yes.
looking at the impulse.
Yes, I am looking at the total energy loss that's required to fail those columns. We are looking at
I thought
that.
we were talking about the jolt, Tony.
The jolt, we're saying with the jolt, by looking at the amount of energy required to fail the columns, you can determine how much velocity loss you should have. And then that's what we look for to discern whether there was a jolt or not. There was no velocity loss, and there should have been quite a bit.
No, there doesn't have to be any, because at no point is the lower structure firmly supporting the upper portion.
It
It's
just
falling
falls
through the
You're right. It
floors.
just falls through it, and
Yes.
and it's not happening just because it cocked off a little bit.
Ryan, could you address very briefly Dave Rogers' comment that Tony and his associate were using some kind of smoothing algorithm that kind of makes the
Yeah.
data
We
unreliable?
we
I
corrected
think they
that.
fixed that. I think they addressed that in one of their revisions.
Oh,
We did.
okay.
We corrected
I may
that.
not. I may not have seen the
We
revision.
corrected that.
Okay.
That was a differentiation. I was using average acceleration. It had no effect.
Okay.
It had no effect on whether.
Well, let's go back to Ryan's slides here and finish these up.
Sure. Okay, so you see what's going on in the lower half of slide number 6. This is where the columns are, or maybe they're going to be twisted beyond that. There's no way the columns are going to contact the lower columns as the upper portion falls. And as we've already computed, as Tony has admitted, the lower floors are not strong enough to support the upper portion, so it's going to fall right through them. It's going to slow the effect, so you're not getting a free fall, but you are never going to get a positive acceleration. It just isn't
It's
gonna
pretty
happen.
hard to have that upper block fall through that lower section with that core there and all the perimeter columns to miss each other with all that. And it certainly isn't happening in the first 3 or 4 stories.
Why not? This shows
Because
it
the
is.
tilt doesn't occur until it comes down 3 or 4 stories. There's
Tony,
almost no
I showed
tilt.
you a picture of it. I showed you a graph
Well,
tracking the
I
top
have,
of the
I have,
antenna.
I have
It's not
something
true.
else in this video I want to point out to Ron, and I hope Gary shows it. And I want to show that the smoke coming out. I want you to look at the smoke coming out of the side of the west wall and the north wall, and it comes out pretty. See it? Does
Yeah,
that look
I've
like
seen
it's tilting? It's coming out completely even on that west wall and in the front. If it was tilting down, the front wouldn't come out until this was all the way down. It
Tony,
comes out.
I see columns bowing and I see the antenna tilting. Why don't
I don't
you?
see how you see
I
it.
don't understand.
The roof line is what I'm looking at. The roof line. The antenna. Look at the roof line. You can see the southwest corner and the northwest corner fall simultaneously, and the whole west wall. The smoke comes out evenly from the west wall, and while it's coming out the north wall at the same time, while this is telling us, well, it tilted south.
Are you saying you don't see a bowing in those columns?
I'm not looking at a Boeing. I'm looking at this, the roof line, the west side, the northwest corner, and the southwest corner. They come down simultaneously. That refutes the notion that there's an initial tilt and then it collapses. It collapses first straight down vertically for a few stories, and then it tilts. And that's saying that what Ryan's saying, and I'm saying there should be a jolt right off the bat at the first stories that collide. There is none.
I'm afraid I don't understand why there shouldn't be an initial tilt, given that we see the tilt at all, given that it
I can
shows
give you
up.
an example. If you took a box, take a beer case box, okay, and take out one side, put a weight on it, and take out one side. It's a pretty strong box, right? Got strong sides. Would you expect that box to collapse if I took one side off it and tilt? I can show you a slide.
Ryan, you see what I'm getting at? Why wouldn't I see an initial tilt? Why wouldn't there be an?
I see one. I don't know what the problem is.
I
If
don't-
you
I
like,
don't-
though, I have additional evidence.
I don't see an initial tilt, and I want to show you when you have a box, when the wind, in the case of wind loading, if the wind, the faces that are normal to the wind, one side, it's like bending if you had a box beam and you bend it, the one side's in tension, the other side's in compression. But the side walls are what resist the overturn. And this just says this south wall bowed. But they only tell us the east and west wall, which are resisting, they're the stiff part, that are resisting this thing tilting or overturning, that they were overloaded by up to 50%. Those columns could take 5 times the load that was on them.
Only if they're hit squarely, Tony. You're not accounting for damage. You're not
I'm
accounting
talking
for
about the initial
eccentricity.
collapse, the
So am
collapse
I, Tony.
initiation. Not
So am
after
I.
it started collapsing, Ryan.
I'm talking about the tilt stage before it falls down. That loads it
Well,
eccentrically.
I-
That breaks the floors, and once the floors are gone, the perimeter will not stand true, and it has no
I was
strength.
getting into this collapse initiation is flawed in the sense that they don't explain how they get the east and west walls. They just make the complete assertion that the instability just continued across the east and west walls.
Can we agree that the very first floor to be hit by the collapsing upper block is not hit flush? In other words, it's not hit like that, it's hit like
That video I showed shows it should have. And the building has massive inertia.
But I see the tilt. You keep
You
saying
don't,
the
I don't
tilt
see
isn't
how you see
there.
the tilt. The smoke's coming out even, and you're saying it's tilting?
I
What
see
does
the
what does
antenna
smoke
tilt.
have to do with the tilt? I don't follow this.
Well, the point is, we need a frame-by-frame analysis. What NIST has provided is not nearly sufficient, and I think they need to do it. They need to show when exactly that antenna tilted. They need much more than that one picture you showed in the report and a bare assertion that it tilted. I'm not arguing that it tilted. When did it tilt? And it's important that he
I
argue.
want to go through Ryan's slides here because we're running out of time.
Yeah,
So Ryan,
let me jump ahead real quickly. Jump ahead to slide number 9.
okay.
This is how you figure out what really happened in the collapse. You don't do these frame-by-frame analyses. I mean, they help. But the thing that tells you the most about the collapses is you pick up pieces, you study how they failed. If Tony is correct, if this thing fell down flush, if the structure resisted, we would expect to see all those columns buckle or compress, as in one of his earlier papers. We don't find this. What we find is that those columns weren't actually loaded properly at all. They were broken off at the bolts. Now, most people don't understand these columns weren't really welded together except at the mechanical floors. They had bolts in between them. NIST recovered 131 of these plates on the bottom of these columns from above, below, near the collapse. 90% of them showed bolt failure. Not explosives, not impact, nothing like that. The bolts came apart. When you see bolts fail, this tells you the structure is being loaded in a funny way. Either the bolts are shearing or they're being twisted. And that's the reason you see such a rapid collapse, because it's not a square impact. It's pushing it to the sides.
I'm not going to argue that, Ryan. These columns come from anywhere from 5 to 8 stories down from the initial collapse.
And above. And several at point of impact.
Your slide says WTC1 floors 90 to 93 and WTC floor 92.
I picked 2 examples that were immediately before, and those 6 floors that you said should have been blown up. So
I don't know, Ryan. I didn't say everything had to be blown up. The perimeter columns had to be blown up.
Okay, let's look at the core. Let's go to the next
core.
Let's look quickly at the core columns on slide 10.
We don't have a lot of core columns, but you see the same thing.
You want to take on how I think it happened? I think the outer core columns were taken down and the corners of the perimeter. The rest of the perimeter columns would have failed at the bolts.
There's no evidence of that.
Well, there's enough. All we have is video evidence. And
no,
you know
that's
what?
not true. We have physical evidence.
And why did they? We don't have. We have very little physical evidence.
We'd like
they
to have more,
saved less
sure,
than
but
0.5% of the steel.
that they saved. They looked at a lot more.
They didn't analyze it. They didn't do any forensic analysis on it, and there's no proof of that.
Well, actually,
There's not
they
a single
did. I've
piece
spoken
of
to
steel.
Alan Pence, who's a metallurgist, professor of metallurgy emeritus at Lehigh, and he was he and his team analyzed recovered steel, specifically looking for chemical signatures. Now, Van's a metallurgist.
There's nothing in the NIST report about that.
Well, you
if
can
that's
read,
true,
you read about it in the popular
if that's true,
mechanics
then NIST
book.
needs to put it in there. I'm talking.
You read it in the popular mechanics book.
My problem
Tony,
is with NIST.
Tony, do you have a single piece of steel from anyone, from any report, that shows evidence of explosives, which is a very characteristic signature?
Well, nobody tested
You have a
for it,
single
Ryan.
piece.
Unfortunately, we are running out of time, and I'd like to say we're running out of time when it's getting good, but it's been good. It's always good, and it's good thanks to YouTube. I can't tell you how much I appreciate your coming in. The stimulating, informative debate. I want to thank Ryan Mackey of NIST. I'm sorry, of NASA. You're not of NIST.
He didn't mean that.
They're all going to say that Ron Wick said you belong to NIST.
I won't accuse you of that, Ryan.
Ryan Mackey of NASA, Tony SZAMBOTI, mechanical engineer. Thanks to both of you. Thank you for watching. I'm Ron Wick. Good night.